Welcome to DACM Insights. This is a podcast where we bring interesting institutional grade crypto projects to institutional investors to hear about the exciting things happening in Web3. We think this space is still the most exciting, highest growth tech that there is in the world. So it's our pleasure to bring some of the founders that we respect and invest behind to present to you the businesses they're building and show you the real things that are happening in crypto. Hi Mike, thanks for joining us.
Hey Richard, how are you?
It was good to get you on to talk because we had a pretty interesting first encounter when I met you up in Singapore, and I think you grabbed my attention because you told me just out of the blue that I'd have 5 robots in my house within 5 years, which I thought was something I hadn't really thought of before. And look, that was about almost a year ago, and at the time I had 0, and I've got my 4th one getting delivered today, so it's been quite prescient. And then we went on to have a discussion about GeoNet and what you're doing and how that relates to robotics, which I think is a super interesting topic that we can talk a little bit more about today. With that as background, thanks for joining. I think the good thing, I've had the benefit of having those chats to you and understanding where you've come from, but it'd be good if you could give your background and how you found your way to GeoNet.
Yeah, so my background is really in the field of sensors and navigation for autonomous systems, so things like robots and drones. And I've been working on that my entire career. I went to UC Berkeley, graduated from Berkeley. I started a company in the field of inertial measurement units, really basically navigation systems for drones. And I sold that business back in 2011. For roughly $50 million. $32 million was to a U.S. defense company, $18 million to, we sort of split the business, half defense, half civilian, $18 million to a Chinese semiconductor company. This is maybe 15 years ago now. So I've been working in the field, and then after that, I got into like LiDAR-based mapping systems, and then I started a company that's doing extremely well for a silicon photonic optical gyro, used in sort of a lot of drone and underwater vehicle applications. So really long background in sensors and navigation. And one of the classic problems in navigation is trying to use GPS to accurately navigate, especially in autonomous systems. The basic GPS accuracy of 2 to 3 meters is not nearly good enough in order to sort of like get back to a charging station or to map out a perimeter or stay inside of a lane on a self-driving car. What you really need is a couple of centimeters. And to get to that couple of centimeters accuracy, you need a network of satellite reference stations. People have been trying to build these satellite reference station networks for a long time and haven't been able to really scale them. And that's where the whole crypto element comes in. So I saw a project, kind of the OG deep-end decentralized physical infrastructure network project called Helium, and I saw what they were doing with, at the time, IoT hotspots, and I realized this type of technique could be applied to the field of navigation, and wrote up a white paper on that topic that was published by the Institute of Navigation and got Best Paper Award. And really, as the industry thought this idea was crazy but had some potential, and so we launched the project in about March 2022, and here we stand in May of 2025 with over 17,000 reference stations, about 2.5 to 3 times larger than any other network on the planet. So it's been a really successful way to actually solve a kind of very difficult age-old problem. And the key to it is using kind of blockchain and crypto rails as a mechanism to connect supply and demand. So people are incentivized to purchase and set up these stations independently in a decentralized way, to set them up correctly, to earn the GOD token reward. And then people use those stations for all kinds of applications, from robots to drones to autonomous farming systems to precision agriculture, survey, geotechnical measurement, all kinds of different applications. And when they use the system, they pay for it. That affects the burn of tokens. So we buy back and burn 80% of the fiat revenue generated from the network. And the network usage is growing and growing and growing. We have about 15,000 users on it a day right now that are directly using GeoNet. We also have a number of partners that purchase wholesale data from us, and those have their own set of users on top of the 15,000. So it's really been very effective and successful in terms of creating a precise global reference network for really any application that needs high precision location.
Yeah, I think that's one of the things we found super interesting when we started to look more into GeoNet. It's that sort of next stage of sort of crypto companies that are providing services to non-crypto users, but using crypto for what it's good for. And in your example, using the network dynamics to roll out a network faster and cheaper than I guess your peers can. So to put that in perspective, I guess, for us as well, could you contrast, I guess, the size and how quickly you've rolled out your network compared to your competitors that have been around, as I understand it, for a long time?
Yeah, so people have been working on this problem for about 20 years. And I think they've been trying to steadily grow the networks. The cost of doing deployments in a centralized way is really phenomenal. I mean, you have the cost of the hardware, and we've been able, through the marvels of modern semiconductors, reduce the cost of hardware quite significantly. But that's just sort of one piece. There's also the cost of securing a location, getting access to it, getting internet, and setting it up. So if you look at a typical centralized deployment, it's going to run 25 to 50 grand per station. And then it's going to have ongoing operating costs of, $3,000 a year on the low end to $5,000 to $10,000 per year on the high end, depending on the location. And that's expensive. When you multiply that out to a large network, that's quite expensive. But it also takes tremendous time and resource. So these centralized locations, they require typically permitting processes. A lot of them will require you to pull your own internet, and then you have to pay them, and paying them on traditional rails if they're all over the planet and all different kinds of countries, which is what you need for a global satellite reference network. You need stations everywhere. We have stations in Mauritius, Fiji, all kinds of places. Actually, just the mechanics of trying to pay all these people is very difficult, and so you don't end up paying them very often, which means that they're not paying that much attention. So the mechanics of just being able to distribute tokens daily to the host in order to keep them, working towards a good, reliable network. And when there's issues, they don't receive the tokens. That's a kind of a very instant control mechanism to improve the quality. So it turns out, without crypto rails and without a blockchain system, this problem is incredibly difficult. And that's why no one's ever really done it. It's because it's just too hard. And, at the same time, as we've been able to use the blockchain to solve the problem, the market's really been working in our favor as a sort of trend towards physical AI and this build out of consumer robotics, consumer drones, things that can take advantage of the network is also exploding at the same time. So there's also a bit of very good timing with respect to GeoNet, and that this infrastructure didn't exist before. It was too expensive to put in. We were able to use the crypto mechanics to do it in. Then that creates additional demand, and so you get a network effect. And similar to a lot of network effects, like something for an Uber or even a social media thing, where the first mover is able to really build up a big moat. I think we've successfully done that, and we've successfully proven that the network is extremely reliable and resilient, and that's just attracted a lot of users. And I think it will continue to grow as more and more of these kinds of physical AI devices, whether it's a robotic lawnmower or even a full humanoid, want to take advantage of precise location.
Yeah, and we'll come to your roadmap, the robotic roadmap that you put out, I think, in the last 24 hours. Yeah, one of the things that struck me when I bought a miner, and DACM's been mining the network for some time, was just the incredible coverage. Like, even in down here in the most remote parts of Australia, people had already put up a station in the 20-kilometre hexagon, way ahead of us. How did people find you, and how do you think the dynamics has worked to build out those 17,000 users? Because that's a lot of people to hear about a pretty unique piece of technology, and then go to the effort of buying their own station and putting it up and being part of the network. What do you think has driven them to do that? Who are these people?
I think there's a lot of people into crypto. Yeah, so I think that I credit a lot to the original OG project, Helium, and that they did kind of build an awareness of the technology, and that's been helpful. And then just the popularity of Web3 and crypto in general I think, brings a lot of people in. And so that gets a lot of the work done. And then another thing that's worked really in our favor is that the users of the network have had this problem, and they haven't been able to find a good solution. And so some of the users have put up stations. So they're in Australia, for instance. We have a wonderful customer, Agri Automation, that's operating both in Australia and New Zealand, and they're operating out in rural areas, and they've set up myriad stations for their customers and act on both sides of the network. So they're mining and enjoying the benefits of mining, but they're also supplying the data and services to customers of a variety of different precision agricultural products, from simple, small robotic devices like the Burrow device, which can move loads around, to more fully complex, fully autonomous tractors. And in Australia, The cost of labor is high. It is a big farming country, but there's a lot of regulations. Cost of labor is high. Going to full autonomy has been there. Australia is really pushing the envelope on full autonomous agricultural operations because of those factors. So we do see quite a few Web 2 customers now have jumped in and started to set up tokens, mining stations, mine tokens, and really understand the entire operation. We have a lot of that going on in drones as well. Drone service providers that do drone scanning, drone mapping, drone photogrammetry. Those guys have set up quite a lot of stations themselves as well. And that gets into some of the sometimes more remote areas. We have a lot of guys doing mining operations that will set up stations. And great thing is, those stations will be there forever because these guys, their businesses are long term. They're doing the same thing year after year after year and providing coverage in areas maybe that there are not quite as many crypto people. But, they see this is a way that can they can really run their business on top of GeoNet. So that's a really interesting dynamic that's occurred as well.
So what's the most remote one you've found, Mike?
Well, I think that they're definitely, we've got a station in Svalbard, we have Iceland, Mauritius, Guam, Fiji. Oh, I think maybe the most remote might be a DAC. So we have a station at DAC. Now the foundation actually organized that station. We have stations that are used kind of locally for what's called RTK, which is the most accurate form of GNSS, but we also have customers that do PPP, and they need an even distribution of stations kind of over the globe. And so Adak, Alaska is the farthest west Aleutian island. It is the one where you can look out and see Russia from the coast. We have a station there, so that's got to be the most remote.
And you've built up this incredible network, and we'll talk a little bit more about the key users of that as we project forward as well. Are you starting to see more people starting to build on top of the network or wanting to get involved in your network and add on their own use case?
Yeah, I think that it's a foundational. So when you kind of look at robotics, one of the things that's so nice about GeoNet and about GNSS-based positioning is as an absolute reference. You can put a coordinate frame, a coordinate system through the center of the Earth, XYZ, and they call it Earth-centered coordinates. And you get a coordinate out of GeoNet that is an absolute position on that XYZ Cartesian plane, 2 centimeter accuracy. So what that means from a robotic point of view is you're creating true physical recall. You're able to remember where something is, whether it's a boundary, whether it's a lane marking, whether it's where a door for a building is. You're able to remember that in absolute coordinates and then share that. It's the same for everybody. So if you think about other sensors like LiDARs and cameras, which are very complementary and are an important part of the robotics ecosystem, they're kind of a relative positioning, like this is this far from me, but they're not giving you that absolute global precision. So that foundational global precision creates this sort of institutional memory and ability to share data between robots, maps essentially between robots is very unique and very handy. If you could imagine as a person, if you could remember where everything in your life was to centimeter accuracy over the course of your life, how much more, you never have to spend any time looking for anything. But we can't, as humans, do that. Our robots, when they're connected to GeoNet, can. And that's exactly the power that we enable. So it is pretty foundational, and people like to build on top of that. Good example of something building on top of that's another protocol that GeoNet's quite connected with, which is called ROVER, Robotically Operated Vehicle Research. And they are literally connected to GeoNet with a device that has a LiDAR and a camera, and they are out building high-definition maps of the world and data sets that are directly used by companies building automated driving systems, what we call ADAS systems, and also full autonomous driving systems. And that is off to a very fast start with it in terms of demand generation. So this is a network that I believe is going to generate demand as fast as it generates supply, because the need for the high definition map data is very big, both for simulation, training, as well as ongoing use. And the availability of data is very, very small, because traditionally this has been extremely expensive to go out and collect high definition mapping data. So there's an example of something where you can't do that without the global RTK network. Everything has to be geo-referenced to better than 10 centimeters to be useful in that space. So you start with GeoNet, then you add on to it these additional sensors like LiDAR and cameras, and you end up being able to build actually very efficiently high definition mapping products.
I mean, that leads us to I guess, where we saw where our discussion started when we first met around, robotics demand and the rollout of that technology over the next decade or so. How do you see this playing out? I mean, you're really close to where robotics is going, both at the consumer and the industrial level. Where do you see the next 5 years of robotics going, and how's Geodnet going to play in that?
Yeah, I think that we all have all these screen-based devices today. I mean, I think everybody's got, at least 3, 4 devices that have a flat screen on them, and they interact with the internet and the world through those devices. I think that same level of interaction is going to happen with robots in the next few years for most people. They're going to have a few in their home, a few outside their home. Maybe their car is going to have robotic features. There's probably going to be drones in their neighborhoods helping with surveillance and security, maybe doing delivery of goods to them on an ongoing basis as drone delivery, I think is going to start to really ramp up in 2026. So I do think there's going to be a real explosion of robotic usage, their productivity. They have an ROI. I mean, that's the essential salient thing about these machines is that they have a real ROI. They make your life better and easier. And it's really just been technology barriers. Like we haven't had the AI, we haven't had the compute, we haven't had the sensors. That is all over the last few years started to change, and it's really reached this inflection point. I mean, I think we all remember this distinct inflection point when the iPhone came out. It was like, aha, you can really do this now. And the first iPhone was a little crusty, a little slow. The screen wasn't that good, but it just sort of exploded from there. I think that's right where we're at in the robotics revolution. We're right around that sort of first generation iPhone today, and over the next decade it's just going to absolutely explode because these devices are so useful and they're not going to be that expensive.
Yeah, I think it's interesting what you say about the ROI, right? Because I mean that's the way I've looked at it. You know how much you pay for house cleaning, pool cleaning, lawn mowing, those sorts of things. So you have a direct cost, I guess you can feed it to the robot. That's an interesting angle I hadn't thought, which is harder with something like an iPhone where it's more of a feel and entertainment buzz. These actually do feel like a kind of disinflationary productivity boost that could potentially work its way around the world.
And I think there are a lot of global trends supporting that. Now, I think with these robots, we have to be pretty careful, and this is part of the whole power of decentralization. I think that we definitely do not want a world where one monopolistic company really controls all these physical AI robots, especially humanoids. I mean, these things
like Blade Runner.
Yeah, it really is. Exactly. I mean, they really are powerful machines and they can do wrong. We see AI all the time go bad. I mean, it's a wonderful productivity tool in our lives. I think everybody is benefiting from, proofreading and idea generation and research and all the different things you can use today's AI for that makes our life easier and better. But you occasionally see the thing just go kind of bonkers on you. You're like, whoa, that's off the mark. And that's gonna happen with these physical AI devices as well. They're gonna go off the mark sometimes. And so if that isn't kind of controlled in a reasonable way, if it's not auditable and traceable, it's gonna be quite dangerous. And I think that's what one of the powers that people don't realize that blockchain potentially has is to actually provide a lot of accountability for these machines. And it sounds kind of theoretical, but actually we see it in super practical ways. Working with a lot of companies that making robots and deploying robots, we do see businesses struggle when there's like debates between the three parties, the person who owns the robot, the person who's sold the robot to the customer, and the person that's made the robot, and they don't know why it's done what it's done, and it hasn't done the right thing. And something like blockchain, this is something I think is a future potential for GeoNet, but something like blockchain could really help provide that traceability and accountability. So if the user trained the robot wrong or set it up wrong, and that's verifiable in a clear way, that then that liability is on them. Whereas if the robot's gone bonkers and that's on the manufacturer, that's on them. And again, it sounds theoretical, but it's actually extremely practical. And I think some of these things are also going to tie into what governments want to do. I mean, drones are incredibly useful tools. They solve so many problems to be able to get up in the air, get imagery, do things, whether even drone spraying, drone photogrammetry, just a ton of use cases, but they're also very dangerous. They're very, very dangerous. And it's something that I think people need to take seriously, that either accidentally or intentionally, these things can, fly into civilian airspace and cause trouble. Well, if these things have smart contracts that are connected to services like GeoNet and others that can all be mitigated in a way that's clean and scalable. And centralized solutions to these problems, I just don't think are really, going to work. So robots and blockchain, I think, have a very happy marriage in the future.
Yeah, I think we see that from a firm perspective. We're super excited. We are at that really interesting kind of inflection point where robotics takes that step from kind of the sci-fi cartoon world into real world use cases. It'd be good just to explain to our listeners the scalability of your network. So do you need to roll out more network as we get more robotics, and how much can it handle, or is it completely scalable from where you're at today?
Yeah, it's pretty scalable. Our network is almost completely built. So that's one of the exciting things. So unlike a wireless network where the more people who are making phone calls, the more base stations you need, this type of precise positioning network is really a sensor network that's compensating for atmospheric errors that are distorting the GPS signal. And so for one area, say for the city of Sydney, if we have the 5-10 stations that we need to cover Sydney, which we already have, that'll cover every user, so every application. So if every single person in Sydney buys a robotic lawnmower, we can handle all of that traffic. If everyone starts using GeoNet on their phone for better driving directions, we can handle that. It's really very scalable. Really, what crypto has solved is a bootstrapping problem, that this is a market where the applications like robotics are kind of emerging, but the need is there today. In order to make those applications happen, crypto has solved that bootstrapping problem. And I think that's really what it's really good for. And it's been able to do that. Now that that network's in place, it can start to self-sustain and continue to grow. And that should drive value back to the token. And it should also allow a lot of interesting systems to be built on top of GeoNet.
No, I think you've built a really interesting asset, and I think scalability is one of the things we really like about it. That if you're in front of what is a pretty big demand boom, you've built a network, and now that network just scales, and that's to the benefit of the token holders, as you said, through the token model you've built. I think, Mike, one of the interesting things to close on would be, your background as you went through is pretty diverse and pretty different for most of the crypto founders we come across. How have you found that transition from going to a traditional growth-focused tech company into the crypto world and all the oddities, the ups and downs that brings with it?
It's a learning curve, Richard. It's a steep learning curve.
That's a diplomatic way to put it, I think, Mike.
I think that, I have a good engineering background. I'm fundamentally an engineer. I still am pretty involved in the tech side of the business. So that helps because crypto and blockchain is quite technical. So that part, I think is good. The market dynamics, the focus on some of the, way the whole dynamic and people get so excited about Fartcoin, for example, I still to this day don't really understand, and I'm not sure I ever am. But there's a certain time you just sort of come to an acceptance and you realize that this is part of the greater good. I mean, we depend on something like Solana as an important part of our infrastructure. We have to build on top of things too. And that all of these different types of projects and people, whether I understand them or not, make the wheel go round. I can get behind that and be excited about it. But it's a learning curve for sure.
Yeah, I think it's really interesting. I think back to the early days of the internet, right? Where it kind of glossed this over now, but people were doing pretty crazy stuff back then as well, right? People throw stuff at a wall, kind of see what sticks and works. I mean, the concept of building a RTK network, married into blockchain incentives would have sounded crazy 3 years ago. Right? Whereas now, look at it.
That's what I put on my original slide. So if you go back and you look at the slides I presented at the ION conference in St. Louis to this very conservative and collegiate crowd of people who fundamentally do research on satellite navigation. It's mostly academics, researchers at very, very large companies, a lot of government guys that work on satellite systems. And so I put on this on all my slides, crazy idea, I was like, I'm not sure people are going to like this idea of using something like a Bitcoin or a crypto type of mechanic in order to build this. But actually people were like, maybe so, because it's been a hard problem. It's been one that everyone in the community, even our competitors, would like to see solved better. Even people you would think of as competitors to GeoNet use the network, because it's just been a very painful problem that's kind of affected the adoption rate of high precision localization and positioning using satellite technology. And it's a really good solution because of that absolute accuracy capability that it has. And so in that sense, while it's a crazy idea, it's been accepted because it just solves a problem that that's hasn't been solvable any other way.
No, and we think that's great, and that's why DACM's been an investor in GeoNet. Very happy with the way the network's going. We think it's a great individual investment around the business you're building, but also a great sign for the crypto space in general, that people are starting to think of other ways to use it for what it's good at, to build out businesses that 3 or 4 years ago we wouldn't have thought had any interaction whatsoever to do with crypto.
Indeed.
So look, on that, no,
I love other projects that are doing stuff like us. It is much easier for me to relate, and I think that there's good synergy between a lot of these deep-end networks, and so we love to see that.
that's great. Well, look, thanks very much for joining us, Mike. Appreciate what you're building, appreciate the journey that you're going on and what we've been able to learn for you, and I hope some of our listeners as well have been able to learn some pretty interesting tech and a pretty cool business that you're building.
Yeah, super, Richard, and I look forward to coming by your place sometime and seeing all your robots, since it sounds
Excellent.
like you're
I'll have that final 5th one by then, Mike, I promise.
Sounds good. All right.
Cheers.
Cheers.
Thanks, Mike. Thanks everyone for listening to DACM Insights. If you found this interesting, please sign up to receive our weekly newsletter, and there'll be more of these coming as we look to introduce more projects that we find interesting across the crypto space to all of you.